Hi students, how are you? So finally your NEET 2024 exam is over, right? And I'm sure that you're waiting for video solutions, of course. So today I am discussing solutions of your chemistry part of the exam, right? So you can check according to your set, right? So dear students, like first question which I'm taking up here is spin only magnetic moment for these transition metal ions. Now we know what is students spin only magnetic moment? What it is? Spin only magnetic moment, it deals with the number of unpaired electrons, right? You know this. And what is the formula of spin only magnetic moment? I can also say that it is under root n into n plus 2 bm, where mu denotes your magnetic moment. And students, what is n? N stands for number of unpaired electron. So I think we understand that if number of unpaired electrons are same, yes, your magnetic moment would be same. So rather than calculating it all, we can just fetch out, no, which have same number of what? Unpaired electrons. See, if I talk of first Ti, what is configuration of Ti students? It is argon, 3d2, 4s2. And if I talk of Ti plus 3 means it has lost 3 electrons, yes? And when electrons are lost, they are lost from the outer shell, then we proceed towards inner shell, yes? So for Ti plus 3, what will be configuration? It will be students argon 3d1 4s0. So here, even if I don't write also, we evidently know that number of unpaired electrons are what? It is 1. Next students, jumping to Cr plus 2. We all know, no, that Cr has students exceptional configuration. What it is? Argon 3d5 4s1. Yes? What we have to check? We have to check for Cr plus 2. Plus 2 means again it has lost 2 electrons, yes? And it will lose, as I stated, from outer to the inner shell. It will proceed, yet. So one electron will go from 4s, other electron will go from your 3d. So how many unpaired electrons it has, students? We know D has 5 orbitals, yes? 4 electron. According to Hund's rule of maximum multiplicity, I will fill it like this. So how many unpaired electrons it has? 4. So see, it has unpaired electrons 4. Ti has unpaired electron 1. Let's check. Now going to Mn plus 2. Students, what is configuration of Mn? Mn configuration is argon 3d5 4s2. So what will be configuration of Mn plus 2? It will be students argon 3d5. Evident. How many unpaired electrons it has, students? It has 5 unpaired electrons. So what is N here? It is 5. Not matching till yet, right? Next, talking of Fe. What is configuration of Fe, students? Argon, atomic number is what of Fe? 26. Here for Mn it is what, students? 25. Here for Ti, what it is? 22. For Cr, what it is? 24. Atomic number, yes? So students, for Fe, configuration is argon 3d6 4s2. If I talk regarding configuration of Fe plus 2, it will be what? Argon 3d6. 3d6. What will I do? I will use two laws to fill up. First is Hund's rule, that I will fill up one electron each in these degenerate orbitals. Yes. After each orbital has one electron each, I will pair. According to which rule? Pauli's exclusion principle, that they will have opposite spin paired. So how many unpaired electrons it has? It has 4 unpaired electrons. Correct? So unpaired electrons are same for here, no? See, we're here same. It has how many? 4. So it is same here and here. If I talk of total spin also is half into number of unpaired electron. Yes, that also is same for these two. So I get my answer. It is what, students? B and D. If still we want to check for SC, let's quickly check. Students, for SC it is argon 3D1 4S 4S2. Yes, because atomic number is what? 21. So students, configuration of scandium plus 3 would be argon 3D04S0. No unpaired electron. This is diamagnetic. How many unpaired electrons it has? 0. So we got our answer. It is B and D, right? Okay, let's move to now next question. Check this, students. We have to discuss order of stability of carbocation. We know now that generally allylic, benzylic are more stable. Then comes 3 degree, then 2 degree, then 1 degree. Here not required, but if in some cases the carbocation is making compound aromatic, yes, it is more stable. So proceeding according to what we are given with, see here this carbocation is first 2 degree, yes. This carbocation, since it is directly attached to just one carbon, yes, it is what, students? 1 degree. Here it was attached to 2 other carbons, yes. Here this carbocation is attached to again 2 other carbons, so 2 degree, yes. This carbocation is attached to 3 other carbons. Check 1, here 1 carbon, 2. Total carbons 3. So it is, students, what? 3 degree carbocation. No concept of resonance to be considered here, right? So very simple. What is our answer? Our answer is option 4, right? Okay, let's check our next question. See, students, I'm sure you must have studied this exception very clearly, that in group 15 NH3 undergoes hydrogen bonding, H2O undergoes hydrogen bonding, HF undergoes hydrogen bonding. So they show exceptional order of their boiling points because of hydrogen bonding, melting points also, yes. And one more concept, students, we know that if I have to compare between these rest elements of group 16, top to bottom, mass is increasing, size also increasing, right? So van der Waals forces are increasing because, students, our van der Waals forces, they are directly proportional to mass, molecular mass I'm writing mm, also directly proportional to what? Surface area. So students, generally what is deciding factor in rest of these? It is van der Waals forces. It is increasing top to bottom. So what is happening, students? Boiling point is increasing. See, from sulfur, because we know, no, what are our group 16 elements, students? Group 16 elements are oxygen, sulfur, selenium, TePO. I'm sure you know this trick, no? Usse tepo, right? So when we move from sulfur to PO, size increases, van der Waals force increase, boiling point increases. But our dear H2O, because of hydrogen bonding, we know what is hydrogen bonding, students? Hydrogen bonding is H attached to electronegative atom. It develops partial charge. See, if O has del negative, H will have del positive based on electronegative difference. Yes, electronegativity difference. Similarly here, H has del positive, it has what? Del negative. This H can interact with the other O. of the other molecule. Likewise, this H can further interact and so on. This O can also interact with other H, yes. So this is, I'll correct this out. So this is, students, are hydrogen bonding. And hydrogen bond being a type of dipole forces, it is stronger than van der Waals forces. So this hydrogen bonding makes boiling point of H2O exceptionally higher. So this order is precise of boiling point. Check this. Let's read the second statement too. Second statement says, on the basis of molecular mass, yes, H2O is expected to have lower boiling point, correct? Correct. What we had expected, our expected order was, students, that H2O should have lower boiling point. Then comes your H2S, then H2SE, then your next elements Te, then comes your next elements H2PO, right? But here we are concerned only till Se. So I will discuss till Se, right? This is our expected order. But students, due to hydrogen bonding, what is observed? What is observed? We have Te also, right? What is observed? This order is normal, yes. But students, are H2O, due to hydrogen bonding, yes, it will take the position greater than H2Te. So this explanation also seems apt. See, H2 is expected to have lower boiling point than other members, but due to extensive hydrogen bonding, it has higher boiling point. So correct. So what is the answer, students? Both statement 1 and 2 are true. Right, students? Okay, let's proceed. Next question is regarding geometry. We have to discuss geometry or shape. Okay, geometry and shape. Before I start, we know that, no, students, that what is difference between shape and geometry? That first of all, we find, students, steric number. How do we find steric number? It is equal to number of sigma bonds made by central atom, right? Plus number of lone pair. Based on steric number, students, we predict geometry. Correct? What I've written, we predict geometry. But the important concept is lone pair. They account for geometry, but not shape. Correct? Lone pair do not contribute to shape. Let's check, let's start. So dear students, N is an element of group 15. Yes. How many valence electrons it will have? It will have 5 valence electrons. It is linking with 3H. We know H links through single bonds. So see, it is making 3 single bonds with H. So talking of N, students, it has 3 sigma bonds plus 1 lone pair. What is steric number, students? 4. Whenever we have steric number 4, what is the geometry, students? It is tetrahedral. Geometry is tetrahedral. But as I mentioned, lone pair don't account for shape, right? So if you exclude lone pair, dear students, what shape do we get? We get this pyramidal shape. So what is the answer of NH3? It is your this trigonal pyramidal. So where is A1? A1 only in 1. Oh wow. Let's check the rest too. Suppose, students, I am discussing now BRF5. Should we start? Yes. I'm doing on a new sheet, right? Let's use it. So see, students, BRF5. We all know that Br is an element of your group 17, yes? How many valence electrons it has? It has 7 valence electrons. It is linking with 5 Fs. F will link with single bond, yes? So I am putting students 5F, 3, 4 and 5. What I'm left with? I'm left with one lone pair. So what I have 5 sigma bonds plus one lone pair. Steric number is 6. Students, in steric number 6, what is the geometry? Students, geometry is what? Square bipyramidal. But as stated, and you know also, I'm pretty sure that lone pair don't account with shape. It's not included. So if I am drawing my square bipyramidal geometry, it's like this. Yes. And we know in steric number 6 and 7, lone pair come on axial position. What is axial position, students? Perpendicular along the axis. And in steric number 5, where geometry is TBP, trigonal bipyramidal, yes, their lone pair come on equatorial bonds. What are equatorial bonds, students? These bonds which are in plane 1, 2, 3, 4. If I show you just a quick idea, these bonds, suppose Br is in center, yes, the bonds which are perpendicular, these are what? Axial. And the remaining 4 bonds which you'll put, one here and one here, 4 bonds in this one plane, they will be what? They will be our equatorial bonds. So here lone pair will come on axial position. Now just focus on what shape we get excluding lone pair. What shape we get, students? We get square pyramidal shape. Correct? Yes. Square pyramidal. Where is square pyramidal? See, B is 4th. So sure, option is 1, but still quickly let's check. Let's proceed to XCF4. Students, you know, Xc is an element of what? Group 18. How many valence electrons it is supposed to have? 8. But how many F it is attached to? 4. If I attach 4F, yes. So it has 4 sigma bonds and students 2 lone pair, making steric number 6. In steric number 6, what is geometry? Same as previous. It is square bipyramidal. But students, we have 2 lone pair. Put 2 lone pair here. So check. What is the shape I am getting? I am getting, check this shape. This is what shape, students? It is square planar shape. So this one is square planar. See matching? Yes, matching. Correct? Let's check quickly. Last one also. Students, SF6. Now SF6, central atom is what? S. It is an element of group 16. How many valence electrons? 6. Put 6 electrons around S. I've just put. If you want, we can put like this also. 1, 2, 3, 4. One more. Then pairing. Fine. Right? It is attached to 6F. See, I'm attaching 1F, 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 1F. So see, students, it has 6 sigma, 0 lone pair. Steric number is 6. So what? Geometry and shape is same because there is no lone pair. And what is the shape? Shape is, students, octahedral. Or I can also say, either I can say octahedral or we can also say square bipyramidal. Yes. Let's quickly check. What is the option? Oh, octahedral. So we have got our option. Correct? Right. Proceeding ahead. So the question is highest number of helium atoms present in first. Students, helium we already know, no? Helium is a monoatomic gas. Yes, single atom. 1 mole has students Na atoms. So 4 mole will have what? 4 Na atoms. Yes. In this option third, it is given in grams. So students, from grams, you know, no? First I can find moles. This N represents moles. Moles would be what? Given mass 4 gram. And we all know helium has molar mass 4, atomic number 2. Yes. So if given mass is 4 gram, what is molar mass of helium, students? It is also 4 gram. How many moles? 1 mole. So how many atoms would this have? It would have only Na atoms. So till now we know among option 1 and 3 which has more atoms? 1. Yes. Let's check remaining also. Second option. Students, U. What is U? U stands for unified mass. It is same as atomic mass unit. Value is same, right? We know that, students, this is a concept. 4 gram helium means it is mass of, it is, students, mass of, it is mass of 1 mole helium. Yes. But students, 4 AMU or students 4U helium means that it is mass of 1 atom of helium. We know na atomic masses are written in AMU or U, right? So what I'm given with 4U. So number of helium atoms in this would be 4U by 4U, that is 1. Already discussed, 4U has 1 atom, right? Check option 4th now. Now you are given volume at STP. We know, students, volume of 1 mole of any gas at STP is 22.7 liters, right? So how do I find moles from it? Given volume at STP, which is 2.27 liters, by volume of 1 mole, which is what, students? 22.7 liters. So if you solve this, how many moles do I get? 227. You can simplify like this, right? Very basic maths I'm doing. 227, you can write 1 decimal, no? You'll put 110, correct? So 0, 0 cancel. We get 0.1 mole. If it is 0.1 mole, how many atoms it will have? It will have, students, 0.1 Na atoms. So if we have to compare, this has, students, how many atoms? 4 Na. This has Na. What about third? Only 1 atom. Yes. What about last option? Last option has, students, 0.1 Na atoms. So which has maximum atoms? Obviously option 1. Correct? Okay, let's move ahead then. So this is a question of organic. Yes. Question is, you have to carry out this transformation. How will you carry out? If I just look, alkene into aldehyde, alkene into aldehyde, what can we know? It can strike in my brain also having a hunch of options that first thing I have to do is I have to incorporate, what I have to do? I have to incorporate one OH group here. OH group here means anti-Markovnikov addition, right? If I, sorry, just a minute. If I put OH group here, anti-Markovnikov of addition, and then I oxidize it, I will get CHO. So first thing first, if students in this, I drew hydroboration oxidation. What is hydroboration oxidation? BH3 in presence of THF students in first step and adding peroxide in presence of base in second. What I get? I will get students anti-Markovnikov of product. Yes, one H here and OH here. Clear? This is what students? Anti-Markovnikov of product. Because if I would have, see, look at these options. If I would have just added water, it would have followed Markovnikov addition. OH would have come on this carbon because carbocation is more stable here. Two options are of BH3THF, hydroboration oxidation. And last, also direct water. So these are directly excluded. Now students, I have to oxidize this into this. One is PCC, other choice is alkaline KMnO4. Students, we know alkaline KMnO4, K2Cr2O7 are strong oxidizing agents. So if I would have used this alkaline KMnO4, this OH would have been directly changed into what? Carboxylic acid. It would have turned into COOH. Since I have to do mild oxidation, I will use what? I will use PCC or PDC. So if I put PCC in this, it will convert alcohol into aldehyde. So what is correct option, students? Option 2, right? Here it is this. You can correct this if required in presence of OH minus. And in third step, we are adding this, right? I'm sure it's clear. First we did anti-Markovnikov addition, then we oxidized using PCC, correct? Okay. Very simple, students. I'm sure you would have scored marks here. Students, the word iso, like isomer, isothermal means iso means same. Therm deals generally with temperature. So what is isothermal process? It's a process carried at fixed or constant temperature. Yes. So what is correct answer? It is carried at constant temperature. A2, 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 only one. See, so easy. You got the correct answer. Still, let's match. Isochoric. What is isochoric, students? Choric word is used for volume, right? Isochoric means process carried out at constant volume. So what is the correct option? See, bar. Bar, it's a unit of pressure only. So isobaric means constant pressure. And what is adiabatic? In which there is no exchange of heat. So it is carried out in such a way that there is no heat exchange. Correct? We already got our answer. Right, students. Okay. Next is, which of the following alcohols react instantaneously? Instantaneously means, students, in seconds with Lucas reagent. Students, now, what is your Lucas reagent? Lucas reagent is concentrated HCl in presence of ZnCl2. See, students, whenever in alcohol we put H plus provider acid, it always gives you carbocation. Check, see, ROH. If I am putting H plus, yes, in first step, it will take one H plus and form ROH2 plus. This is lost, and what we get? We get carbocation. So students, this Lucas reagent follows which pathway? It is SN1 mechanism. Whenever carbocation is formed, it is 1. Why SN1? Because there is substitution. In the final product, what happens? Once carbocation is formed, Cl minus acts as a nucleophile from HCl. Cl minus will go and attack on this carbocation. And students, if you know, alcohols are highly soluble in water because of hydrogen bonding. But in this reaction, when alkyl halides like alkyl chloride is formed, it is sparingly soluble, leads to turbidity. Rate of turbidity helps to decide what is degree of alcohol. Is it 1 degree, 2 degree or 3 degree? Yes. And students, we already know that order of stability of carbocation is what, students? 3 degree, 2 degree, 1 degree. Yes, of course. Benzylic allylic is prior to 3 degree. Yes, correct. So, oh yes, also you know, no, 3 degree with Lucas reagent give turbidity in seconds, instantaneously. 2 degree gives turbidity in few minutes. 1 degree, no reaction, or we say turbidity in hours. So what I have to check? I have to check which is my 3 degree alcohol. That is will be my answer. Correct? See, this alcohol, since OH attached to carbon, which is further, you know na, how do you check degree of alcohol? We check the carbon having OH is directly attached to how many other carbons, right? This carbon having OH is directly attached to only one other carbon, right? So students, it is your 1 degree alcohol. This carbon having OH is attached to 2 other carbons. So this is your 2 degree alcohol. This carbon having OH is attached to one other carbon only. So it is your 1 degree alcohol. This carbon having OH is attached to 3 other carbons. So students, it is your 3 degree alcohol, and this is the answer. Simple. Correct? Okay. Next. Again, very basic question. They have asked in which case Kp and Kc are not equal. Students, what is relation between Kp and Kc? First thing first, we know both are equilibrium constant. Yes, we use Kp generally for gases when their partial pressures are given. Yes, Kc is defined in terms of concentration. So there is a relation between them. What is the relation? Direct question, direct formula. It is Kp. Kp, students. What is the relation, students? That Kp is equal to Kc RT raised to the power delta Ng. What is, students, R? R is your gas constant. What is, students, T? T is temperature in Kelvin. What is T? It is temperature in Kelvin. So students, simple. The concept is, students, if delta Ng is equal to 0, if this power is 0, we know na, anything raised to the power 0 is 1. This term whole will become 1. Then what we get? We get Kp is equal to Kc. So catch for this question. Can we quickly check in which of these options delta Ng is 0? Then Kp will be equal to Kc. Yes? Now, if someone among you is thinking, what is delta Ng? Students, delta Ng is change in gaseous moles. So students, what is delta Ng? Delta Ng is sum of gaseous moles, only gaseous we have to take. G stands for gas. Gaseous moles of products minus sum of gaseous moles of students reactants. I'll show you. Let's check. See, if I'm finding delta Ng for this reaction, reactant side only one gas. This side one gas, one more gas. How many gaseous things? Two. Here if nothing is there means the stoichiometric coefficient is 1 only. So 1 plus 1. How many moles of products? 2. Minus 1. What is delta Ng? 1. Here delta Ng is not equal. If delta Ng has some value, obviously Kp, Kc will be different. Yes? Let's check next. 1 mole, 1 mole, 2 moles. What is it? 2 minus 2 is 0. Delta Ng is 0. Thank God it is 0 because then Kp, Kc are equal. Next. 1 gaseous mole, 1 gaseous mole, 1 gaseous mole, 1 gaseous mole. So students, 1 plus 1 minus this when you do. 2 minus 2, what it is? 0. Here if we check, see, 1 gaseous mole, 1 gaseous mole. 2 minus 2, again it is what? 0. So students, in option B, C, D, delta Ng is 0. Same. Moles on reactant side and product side. Only case when delta Ng is different is 1. So this is our answer, right? Fine. Let's proceed ahead. Again, very basic question. Students, we know na, what are quantum numbers? They give complete information about an electron. Which shell, which subshell, which orbital, how it is oriented. It gives you all information. So starting with the principal quantum number n, it gives you energy, it gives you size, it tells you about radius. So let's check option, shape, size, orientation. Of course, n can tell you about size of orbital, right? Next, L. L tells us about, students, what? Subshell. Like, you know, if L is 0, it will be S subshell. L1, P subshell. L2, D subshell, right? So what does L tell you? L tell you about the shape of orbital. Because S we know na, it's spherical. P we know it is dumbbell shaped. D we know it is double dumbbell shaped, right? So it tells you which subshell and what shape it will have. Students, MS, spin magnetic quantum number, tells you about the orientation of spin of electron. You remember we say this, like if MS is plus half, we say assign it clockwise. If MS is, students, minus half, we say assign a different orientation of spin, say anti-clockwise. So what does MS tell you? It tells you about orientation of spin of electron. So correct option is this. Lastly, what does ML tell you? It tells you about the orientation of orbital. Because do you remember, like for D, if I talk, for D, students, L value is what? For, let me just amend it. Students, for D subshell, what is value of L? It is 2. And you know, if L is 2, M value ranges from minus 2 to plus 2. And D has what? 5 orbitals. dxy, dyz, dxz, dx square minus y square and dz square. Yes? And we generally assign value 0 to dz square. Likewise, all have different shapes, no? Orientation along different axes. So this ML tells you about the orientation of orbital. So let's find our option. A is third in these two. B is fourth in these two, okay. C is 1 only in this and this. So this is our correct match. right? Okay, proceeding ahead. Next, students, aniline does not undergo Friedel-Crafts alkylation reaction. Yes. What is Friedel-Crafts reaction, students? We treat, students, we treat benzene or benzene derivatives. Yes. You studied no, in grade 11th also, and it was repetitive in grade 12th also. Electrophilic aromatic substitution reaction. One of the type is Friedel-Crafts alkylation. Yes. What reagent we use? Students, we use alkyl halide in presence of anhydrous AlCl3. Now the problem with aniline is, students, N is what? Electron rich. This is your Lewis acid. What it is, students? It is our Lewis. It is our Lewis acid. So students, N being electron rich, correct? And AlCl3 being Lewis acid, having vacant orbitals. There is a tendency of N to donate its lone pairs into vacant orbitals of Al and form a complex which deactivates aniline. Which deactivates aniline, students. Yes, it is NH2 plus. Why plus? Because it is giving electrons, dative bond, right? To what? AlCl3. It has negative charge. It is what? Deactivating the aniline. So it does not undergo Friedel-Crafts alkylation reaction. Statement 1 is correct. Right. First statement. Let's check, students, statement 2. Statement 2 is aniline cannot be prepared through Gabriel synthesis. What is Gabriel synthesis? Gabriel thalamide synthesis. Yes, where you take thalamide treated with aqueous KOH. Yes, phthalic anhydride we start with thalamide, right? So, Gabriel thalamide synthesis, in the light of, okay, we have to check. Let's quickly review what is our Gabriel thalamide synthesis. Check this. In Gabriel thalamide synthesis, students, we first take our thalamide. This is your, benzene with 2 COH is called your phthalic acid. If we make amide from these, it is called what? Thalamide. And what we put in the first step, we put a base. What does base do? Students, base abstracts a proton. And what we get? We get, students, anion on N. We get N minus K plus. Now this N minus electron rich N acts as a nucleophile. Then in the next step, it attacks on alkyl halide and X goes. And students, further mechanism is continued. Then we add base. If we add base again, what we get, students? Base will attack here, base will attack here. It leads to formation of RNH2 and R phthalate ion. Right? K plus along present. Now first pointer is that Gabriel thalamide synthesis is only used for 1 degree amine. Second catch is that it is attacking on Rx. So suppose, students, I have to make aniline. What should be my Rx? In order to make aniline, for aniline synthesis, Rx required should be, students, this, no? Benzene attached with some halogen. But due to resonance, this CX bond acquires partial double bond character. This does not break. So, this anion formed cannot attack here to form aniline in the last step. So, this line is clearly written in NCERT also in grade 12 amines chapter, that because of this double bond character, this anion cannot act as nucleophile and hence aniline cannot be formed using Gabriel thalamide synthesis. Okay, right. So dear students, both statement 1 and 2 are true. Correct? Yes. Okay, let's proceed then. Next is intramolecular. What is intramolecular hydrogen bonding? Hydrogen bonding taking place within the same molecule. What is intermolecular? Intermolecular means between different molecules. Yes. This is our favorite example we have seen always. In this orthonitrophenol, there is intramolecular hydrogen bonding. See, this O and H can interact with each other. Correct? Or if you want, we can draw it like this also. We can draw like this also. N dative bond O, double bond here with O. O has del negative charge. Why? Because it is more electronegative. It is interacting, students, with our H. Correct? So let me show hydrogen bonding with a dotted line and a different pen. H attached with electronegative atom interacting with other electronegative atom. This is happening in the same molecule, so it is your intramolecular hydrogen bonding. Here it is not possible because of distance factor. Here again, para undergoes extensive intermolecular between different molecules hydrogen bonding. So correct option is option 1. Right? Okay. Next students, it is a simple question based on purification techniques of organic. You know this, see, on heating, some solid substances change from solid to vapor. Yes. Without passing through liquid state. What is this technique used for purification of such substances? So basic. From lower grades we are studying. Solid to gas directly. What it is? It is sublimation. Direct question. Right? Okay, next. Students, next question is about entropy. What is entropy? Denoted by S. Entropy is randomness. Freeness. You know, gases have more entropy. What is the concept? Gases have more entropy than liquids. Then, with few exceptions, like boiling of egg, right? Then comes your solid. So whenever gaseous moles are increasing or liquid is changing into gas, entropy is bound to increase. It's supposed to increase, right? See first, liquid evaporates to vapor. Liquid is changing into vapor, means liquid into gas. Obviously entropy increases. Temperature of solid lowered. See students, when we increase temperature of anything, its kinetic energy, random motion increases. So entropy increases. But when we decrease temperature, movement of molecules also decreases and entropy decreases. So in this case, when we are lowering temperature, entropy decreases. Third, here it is solid. Solids. Solid is giving, leave solid, gas, more gas formed. So obviously entropy will increase. Here gaseous moles are 1. Here gaseous moles are 2. How many gaseous? Don't say here Cl2, 2Cl. I am talking of moles. Here gaseous moles are 1, here 2. more gaseous moles in product side. So obviously entropy increases. So what is your correct answer? It is A, C, D, right? Okay, students, next question. Again, very basic. Group 16, I already told you in previous question, students. In group 16, which elements are there? Us, se, tepo, right? These elements are there. Top to bottom, when we go students top to bottom, what happens? Size increases. Yes. If size increases, electron negativity decreases. Tendency to pull electrons decreases. Electron gain enthalpy becomes less negative. Tendency to lose electrons become easy. Or other way I can say metallic character increases, yes. So if you check O, Se, what we have? O, Se, Te and Po. And they are saying which is least expected to gain electrons, because -2 state will come when it gains electrons, right? So obviously last element will have least tendency to gain electrons. It is on the metallic side, more metallic character. So answer is what? Po. Correct? Right. Next, see students. This question directly we can do, quickly check. So students, in H2O, 2O2, what is happening? O is in -2 state going in 0. Any doubt how? I'll show you here. Students, we know that when H is present with non-metals, it shows oxidation state of +1. So 2 hydrogen are there. Oxidation state of +1 plus X equal to 0. What is oxidation state of O? -2. We can write equations also, directly also we can do. O is going from -2 to 0. What is N factor? What is N factor, dear students? How do we calculate N factor? N factor is equal to what is N factor, students? N factor is equal to mod I can take mod of change in oxidation state into number of atoms undergoing change. If you have a doubt why not H, there is no description of H in product side, students. Yes. Just see, there is one O going to O2. When you have to multiply with number of atoms undergoing change, we take from reactant side, not of products. Yes. So change is what? Take a mod. -2 minus 0. Mod will be 2 then, right? Into how many atoms? 1. So what is N factor? N factor is 2. N factor is 2. Means 1 H2O requires 2 electrons to change into O2. Because N factor for redox reactions is this only, no? Number of electrons lost or gained per mole. So 1 mole will need how many mole of electrons? 1 mole will need 2 mole electrons. Are you able to get it? See students, repeating. From -2 to 0 it is going. What is change in oxidation state? If you take mod will be 2, no? Mod is to convert any negative number into positive. How many atoms we have? 1. So N factor is 2. N factor is, repeating, what is N factor? For redox reaction, students, N factor is number of electrons lost or gained per mole. Correct? And do you know what is this word F? Students, F is Faraday. Charge on 1 mole electrons is 1 Faraday. 2 mole 2 Faraday, 3 mole 3 Faraday, and so on, right? So when n factor is 2, means 1 mole of H2O2 will require 2 mole electrons. 2 mole electrons means how much charge? 2 Faraday. How much charge, students? 2 Faraday. So first it is second in these two. Let's check next. Students, in MnO4 minus, see, I am finding first oxidation state. Here Mn is present in +5 oxidation state. How? Let's check. See, let oxidation state of Mn be X. How many O we have, students? 4. O with less electronegative atoms, means except F. It shows in oxides oxidation state of -2. So 4O I have multiplied with -2. What is total charge? It is -1. So solve it. What is X? X is -1 plus 8. It is what, students? +7. I'll correct it, sorry. It is what, students? It is your +7. So if I find change, here there is one Mn going from +7 to +2. What is n factor? 5. So students, 1 mole of MnO4 minus requires 5 mole electrons. What is charge on 5 mole electrons? It is 5 Faraday. So correct option for B is option 4. Right? Okay, next. Ca. Ca, if it is just in native state, normal Ca, its oxidation state is 0. When it is forming chloride, you know, Cl is in -1 state. Yes. So here calcium is, students, in +2 state. If you want to find, let's quickly check. For Ca, students, oxidation state I am assuming to be X. How many Cl? 2 Cl. Charge on Cl is -1. So what is X? X is +2. So dear students, when I am finding change, what is the change? Change is 0 going into 2, 0 minus 2 mod. Into how many atoms? Atom is 1 only. N factor is 2. It was easy in A and B because there was just 1 mole. Check option C, students. Here they have said 1.5 mole. So students, for option C, if I just quickly review, 1 mole of Ca needs how much? 2 Faraday electrons. Given in question are 1.5 mole. So 1.5 mole calcium will need what? Simple, 1.5 into 2 Faraday electrons. What is this number? Faraday electrons, or I can say charge. 2 Faraday charge, right? So what is this number, students? It is 3 Faraday. Where is it? It is here. So C, it is 1. Let's check last one. Students, in FeO, direct, we know that O shows state of -2. So Fe is in +2, right? Let's find for this Fe. It is present in +3 state. How? Let's quickly review. We have, students, Fe2O3, correct? Let oxidation state of Fe be X. So 2 Fe into X plus 3 into, what is oxidation state? -2. So what will be X? Solve it. It will be +3. So let's find N factor. It is going, students, from +2 to +3. How many Fe? 1 Fe. So minus, when you take mod of -1, it is +1, right? So what total N factor is 1. So dear students, 1 mole requires 1 mole electrons. How much charge? It is 1 Faraday. So option 1. Correct? Too much info? Alright. Quick review. How we fetched out? First, I calculated n factor, which is what? It is mode of change in oxidation state into number of atoms undergoing change in reactant site. N factor told me how much electrons 1 mole would require. Then I made further calculations according to moles given. It was pretty simple for A, B and D. Only in C, it's 1.5 mole. So how we did, students? 1 mole requires 2, no? 2 mole electrons or 2 Faraday charge. So 1.5 mole will require what? 3 Faraday charge. That's it. Right? Fine. So simple question, students. We know that most electronegative element of periodic table is F. Then comes O. Then comes N. Then obviously C. And the concept is when we move from left to right in periodic table, yes, left to right in a period, electron negativity increases. Why? Because left to right size is decreasing. Tendency to attract electrons is increasing because of increased effective nuclear charge. However, when we talk regarding top to bottom in our group, electronegativity decreases. Why? Because, students, top to bottom, effective nuclear charge is almost same, but size is increasing. Yes, size is increasing. Molecule is more spread out. So tendency to attract electrons, shared pair of electrons, decreases. So till here it was simple. Because we know, no, here we have in group 17F, here O, here N, here C, and Si is present underneath C in group 14. So obviously electronegativity of Si would be less than carbon. So it is option 1. Correct? Right. So students, this is a question again of organic. That a compound has molecular formula C6H14. That means it's an alkane. Because it is adhering to the criteria of CN, H2N plus 2. Right? It's an alkane. It has 2 tertiary carbons. Tertiary means a carbon attached to 3 other carbons. It has 2 tertiary carbons. What is its formula and IUPAC name? So students, if I have to make one compound tertiary, one carbon tertiary, that means I have to attach it with 3 other carbons. Fine. This is 3-degree tertiary. But the criteria is it has 2 tertiary. Let me try making it also tertiary. Is it tertiary? Yes, it seems like. It's also 3-degree. Our number of carbons fulfilled, our carbons total in 6. 1, 2, 3, 4, 5, 6, yes. So that means this is my compound. Let us just put H. CH3, CH3, CH3. Here 3 bonds it has made already. Yes. So one H will come here, one H will come here. Very simple question. We can easily give its IUPAC name. How? First number. Select from one side, move to the other. 1, 2, 3, 4. Is this longest chain? Yes, because if we select like this, 1, 2, 3, it will have only 3 carbons. We know now how we do numbering. We do numbering according to, students, FMCS rule. What is it? It means the order of priority is this. For numbering, for selecting chain. First priority is for F stands for functional group. M stands for multiple bonds. Multiple bond means double and triple. If these two are not there, we give priority to number of carbons. Means since functional group and multiple bond is not there, I try to select a chain which will have maximum number of carbon atoms. Last priority is for substituents. We have to select chain in such a way it have maximum carbons plus maximum substituents. So here, this is my parent chain. These two are your substituents, yes. So what will be name? Name would be 2, 3. Because how we write name, students? First we write name of substituents. It is your 2-degree prefix, right? Quick review, students. Order of naming is this. First we write, students, 2-degree prefix. Then we write, students, 1-degree prefix. Then we write, students, word root. WR is what? Word root. Then we write, students, 1-degree suffix. And lastly we write 2-degree suffix. A glimpse of this. What is, students, 2-degree prefix? It deals with name of substituents in alphabetical order with numbering. What is 1-degree prefix? It is cyclo, used for cyclic compounds. Bicyclo for bicyclic, but it's not in NEET, so cyclo will adhere to. Word root depends on number of carbons in parent chain. What is 1-degree suffix? It depends on nature of bond. Ane, single bond, double bond, triple bond, diene, diene. 2-degree suffix is dependent on your functional groups. So here simple name, what it is? These two substituents are on 2 and 3rd position. So it is 2, 3 dimethyl butane. It's option 3, right? Okay. Felling, again direct question, students. You know felling A is your aqueous copper sulfate. Felling B is sodium potassium tartrate. So felling A is what? It is aqueous copper sulfate. This is, students, your felling B. Correct? Okay, next. Okay. It's also easy question, students. Activation energy. What is activation energy? Denoted by EA. For any chemical reaction can be calculated if one knows the value of. Have you seen this formula? Log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T1 into T2. This formula comes by integrating your Arrhenius equation. What is Arrhenius equation? K is equal to A. What it is? K equal to A e raised to the power minus EA by RT. When you write expressions at 2 different temperature and we integrate it, we arrive at this, right? So if we know value of K, now what is K? Students, K1 is your rate constant at T1 temperature. What is K2? It is, students, rate constant at T2 temperature. What is R? R is your universal gas constant. So students, if we find out rate constant at 2 different temperatures using this equation, we can find E, no? So what it is? By knowing rate constant at 2 different temperatures, we can find what? Activation energy. Correct? Right. Again, question based on Arrhenius equation. What it is, students? K is equal to A e raised to the power minus EA by RT. If I do taking log natural both sides, what I can write? I can write ln K is equal to ln A plus ln e raised to the power minus EA by RT. How I wrote? Students, I know this concept, no? ln of xy is equal to ln x plus ln y. I can break it, right? And ln also has base e cancelled. So it will simplify as ln k is ln a minus ea by rt. Ln and e cancels. So what I am plotting with, dear students, I am plotting ln k with 1 by t. So if this is my y, this will be your mx, this will be your c. So what is slope? Slope is this. Slope is minus ea by r, negative slope. So it should be correct option. This one going down, negative slope. And this, see, here slope is minus ea by r. What is intercept? C is intercept, no? It's ln a. So this part is your ln a. Correct? Simple question. Just knowing the slope you could have done. Correct? Okay. Now match. First is simple, students. This is breaking into two units. What is happening? Ozonolysis, no? When we do ozonolysis, double bond breaks. We put double bond O. Correct? So what is correct match? It is O3 in presence of Z and H2O. Check next. This is giving you this. Look at options. Oh, see, it seems here. Obviously, students, if I do Friedel-Crafts acylation, this is acylation. What it is? It is your Friedel-Crafts acylation of benzene. So when I do acylation, this Cl will go. Benzene ring will attack here on carbonyl carbon. Cl will go and we get this compound. So option B is matched with 1. B1, B1. Students, B1. Oh, B1 is everywhere. So easy option, no? See, B1 everywhere. What was A? A was 4. Where is A4? Oh, two options. Check third. This is my alcohol, 2-degree alcohol. It is changed into ketone. That means it is undergoing strong oxidation, right? Let's check. We have two options here. You know, students, CrO3 in acetone, Jones reagent, causes mild oxidation. But CrO3 in H2SO4 causes strong oxidation. So let me review this option fourth also. Oh yes. This concept we know that if directly attached carbon with benzene ring has at least one H, it can have 3H also, 2 also, but at least one H. Whenever you put alkaline KMNO4, what it gives? It directly gives benzoic acid. So I am sure for D option is your, this option is your 3. For D it is 3. Obviously one option left. So C option is second. It's option number 3rd. Correct? Okay, next. Which undergoes SN1 easily? Students, here this C having Br. This C is attached to only one other carbon, so it is 1 degree. Focus on this C. Focus on this C. This will not undergo SN1 at all. Why? Because of resonance. This bond acquires partial double bond character. Also in SN1, halide is lost and we get carbocation. Always positive charge or radical on double bond is highly unstable. It's not stable. So this won't undergo SN1. Check this. Here it is 2 degree. Students, check this one. C having Br. This is 2 degree plus also benzylic. Benzylic means after loss of Br, the carbocation which is formed Here, it is stabilized by resonance, no? It will get delocalized in benzene. See, if I show you one resonating structure, this bond can move here, no? Positive charge here. And likewise, we can further draw resonating structures. So this positive charge is delocalized in ring. It is stabilized due to resonance. So it is highly stable carbocation after loss of Br. So it undergoes SN1 reaction fastest. Correct? Right. Do you know these resonating structures? If not, I'll quickly draw. You can check, see. I'll redraw it properly. You can review if anybody has a doubt here. See, what happened is we got, I can draw it like this also, no? CH3 here, Br here, Br lost, positive charge is coming. Simple. How can I draw resonating structures? See, this bond will move here, correct? I will get positive charge here. In next step, you know we always move arrow from high electron density to low electron density, yes? This pi bond will move here. So what we get? Positive charge will come here. This carbon is losing electrons. And then double bond is moving here, see? Likewise, in next step, students, there is again shift, delocalization. And what we get? Positive charges coming here. Correct? And what again? This will move back here. So this positive charge here also, 1H is also present. Yes, this is delocalized in the entire ring. So it is stabilized by resonance. Correct? These are resonating structures. Correct. Which is not redox. Redox means there should be change in oxidation state. Check here. Here Zn from 0 is going in +2. Here copper from +2 is going in 0. It is redox. Here KClO3. Cl is in +5 state. How do I fetch it? See, I'm doing it here. We know, students, K is group 1 element. It will show oxidation state of +1. Cl will have oxidation state of X. X means I have assumed because I'm finding, right? There are 3 O. Oxidation state on O is -2. So what is X? X is +5 here. So Cl from +5, here it is going in 0, obviously change. Here from 0, it is going in a state of again +5. So redox. H from 0 is going in +1, Cl from 0 going in -1. It is redox. Fourth is not redox. Why? Because here Ba is present in +2. Cl is present in, here it is C, Ba is present in +2. Cl is present in -1. There are 2 Cl. Here sodium is present in +1. Sulfate is present in -2. Here Ba is in +2 only. Sulfate is in -2. Na +1. Cl -1. Do you see a change? No. It is just interchange of ions. It is double displacement reaction. Correct? So it is not a redox reaction. Next, students, see. Boiling point of 3 isomeric pentanes. Today only I told you, students, that boiling point for non-polar or slightly polar, it depends on van der Waals forces. And van der Waals forces are directly dependent on surface area. And students, branching decreases surface area. Something becomes more compact. Like if I talk of N-pentane, this is structure of your N-pentane. N-pentane. If I talk of isopentane, students, this is isopentane. One methyl group on second position. You know, na, we would was iso when one methyl group is on second position, except except isooctane. It has a different structure, yes? So this is your isopentane. Lastly, talking of students, neopentane. Neopentane has this structure. Neo word is used when two methyl groups. I'm not putting H. Obviously, we can fulfill valency, yes? So neopentane word is used when two methyl groups are present on second position. You can clearly check, students. Surface area is depreciating, right? It's becoming more compact. So order of van der Waals forces is, it is maximum here, then here, then here. So same is the order of boiling point. So statement 1 is apt. Check statement 2. When branching increases, molecule attain the shape of sphere. This results in smaller surface area due to which forces decrease and boiling point decrease. Correct, no? So both statement 1 and 2 are correct. Right? Next. Oh yes. Again very easy. Students, whenever coordination number is 6, it is always octahedral. This is apt. It can be either outer orbital complex, it can be either inner orbital complex, depending on hybridization, which is decided by the magnetic nature of the ligand attached as per electrochemical series, and also it depends on electronic configuration of central metal atom. Here both are present in coordination number 6. So even if hybridization is D2sp3, even if students it is sp3d2, both will have what shape? Octahedral. If inner D is used, it is inner orbital complex. If outer D is used, it is outer orbital complex, but it is octahedral for these. So without solving, you know statement 1 is apt. In order to check diamagnetic or paramagnetic, now we need to know how many electrons CO plus 3 has. Yes, plus 3. And how will they exist? Will they pair up? Will they remain free? Know one thing, students. Here NH3, it acts as strong field ligand. It is strong enough to cause pairing if required. F minus is your weak field ligand. We can check in both these cases. CO is in plus 3 because NH3 is neutral, it's in plus 3. F has minus 1 state. If you find oxidation state of CO, how do you find? X plus 6 into minus 1, it is minus 3. What is X? X is plus 3. Both have CO in plus 3. So students, configuration of CO is argon 3d7 4s2. Configuration of CO plus 3 would be 2 electrons from 4s, 1 from 3d is lost. So 3d6 4s0. Now with NH3, or let me draw quickly, I'll show you ground state. How it exists, students? 3d6 means you have to put 6 electrons in D. D has 5 orbitals. 1 electron, 2, 3, 4, 5 and 6. It exists like this. It will remain like this with it will remain like this with F minus. No pairing. Why? Because F minus is your weak field ligand. But CO plus 3 with NH3, how it exists? This is obviously argon configuration. I'm talking of 3D. If students, 1 electron from here moves here, pair. 1 this moves here, 2 d orbitals would be vacant, right? Yes, which can be used to get this configuration D2sp3. So NH3 being strong will pair up electrons. And obviously it will give what configuration? D2sp3. Here what it will give? sp3d2. Since electrons are paired, so with NH3 it is diamagnetic, non-paired electron, and with F it is para. So again, both statements are true. Do you see in this your paper, all questions have both statements correct. But there is no pattern. By chance, maybe it is true, right? Okay. Next. Again, so easy. You know, ethane is alkane, students. Between carbon, carbon, there is single bond. What? Only one sigma bond. Easy question, very easy. Ethene, there is double bond. We know between atoms when students multiple bonds are formed. Only one is sigma, rest all are pi. So students, what? This bond is sigma, other has to be pi. It has one sigma, one pi. It has what? One sigma, no, one sigma, one pi. B4, 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 B4. A3, A3, A3. C2, will come to this. Talk of ethyne. Ethyne configuration is C triple bond Cl, kind. So it has 1 sigma 2 pi, 1 sigma 2 pi, D1. Let's now talk of C2. Students, C has atomic mass 12, atomic number 6. So if I talk of C2, it will have total 6 from each carbon, total 12 electrons. You know, we have to draw MO diagram. According to MO diagram, we fill electrons according to energy order from lower to high. So, according to students' molecular orbital theory, grade 11th chemical bonding, electronic configuration, EC is electronic configuration of C2, what it would be? It would be sigma 1s2, then sigma star 1s2. How many electrons used? 2 here, 2 here. Then sigma 2s2, sigma star 2s2. How many electrons used? 1, 2, 3, 4, 5, 6, 7, 8. 8 used. Now you know students, due to sp mixing till N2 means before O2, energy of your 2pz is higher than your pi 2px and pi 2py. When I say pi 2px, pi 2py, there are two orbitals having same energy. So total 4 electrons can come in it. So I will have to fill. How many electrons I filled? 8. How many are left? 12. Means 4 electrons left. So I will have to fill remaining electrons in pi 2px having same energy. Equal to means having same energy as pi 2py. First 1 electron here means these are the boxes, dear students. This is your pi 2px box. This is your pi 2py box. According to Hund's rule, put 1 electron because they have same energy, then pair. So 2 electrons here, 2 here. Have I used 12 electrons? Yes. Then I find bond order. How do I find bond order? Bond order is number of electrons in bonding molecular orbitals minus number of electrons in anti-bonding molecular orbitals by 2. Students, the one having lower energy where there is no star, they are your BMO, bonding molecular orbital. The one with asterisk sign, they show ABMO. Now check, how many are your bonding molecular orbitals? 2 here, 2 here, 4, 5, 6, 7, 8. 8. Minus, is pi BMO? Yes, there is no star, no? We make pi star 2px, pi star 2py also, right? So 8 minus, how many anti-bonding? 2 here, 2 here, 4. Bond order is 2. This is sure. In C2, bond order is how many bonds it make? It will make 2 bonds. Bond order is coming to because of these electrons in pi orbitals. See, bond order of this and this cancels. Sigma 1s, sigma star 1s. This cancels. We have 4 electrons contributing to bond order of 2 in pi. So we say that C2 makes 2 bonds using pi electrons. So C2 has, students, what? It has 2 pi bonds. Right? Okay. Next, very simple. See, students, you know what is Henry's law? Henry's law states that partial pressure of gas is equal to kh into x. Chi, you can say. This chi is your solubility. What is this kh? Kh is Henry's law constant, already told in question. So for three gases, we are given Henry's law constant. Correct? The concept is, students, at constant pressure, if I keep this constant, if left side is made constant, obviously right side is constant, no? If right side is constant means if kh is increased, chi solubility has to decrease. If solubility increases, kh has to decrease. So at constant pressure, students, kh is inversely proportional to solubility of gas. Henry's law deal with, students, solubility of gas in a liquid. Simple concept. The gas which has least kh will be most soluble. Check order of kh. What is order of kh, students? I think this is least, yes, 10 raised to power minus 5 for B. Then comes C, then comes A. So students, order of solubility would be what? It would be reverse, right? It would be A, then C, then B. Option third. Correct? Okay. Energy. According to Bohr's model, chapter atomic structure, what is order of energy? E is equal to E naught. Correct? Z square by N square. Where, students, we know this. What is Z? Z is, students, atomic number. What is N? N is your shell number. Correct? So they are saying energy of electron in first shell of helium plus. Students, if I'm finding energy of helium plus for first shell, E naught is a constant, no need to substitute. We know value, minus 13.6 electron volt. What is Z? Z is atomic number. For helium, atomic number is 2. What is shell number? First shell, 1 square. This value is given what? Minus x. Okay, they have given in joule. Although not required, E naught in joule is 2.18 into 10 raised to power minus 18 joule per atom, but not required. We'll cancel out. I have to find energy of Be plus 3 in second shell. In, students, what? Second shell. Second shell means your N becomes 2. Second shell, 2 square. Be, ha, he, li, B. Atomic number is what? 4. 4 square. Correct? If you solve it, this number I have to find. Now first, if I solve this, let me solve it a bit. If I solve it, students, what I get? E naught. 4 square by 2 square. 4 square by 2 square, can I write? 4 by 2 square? Yes. So it will become what? E naught into 2 square. Same value as this. So value of E naught into 2 square is minus x. So this also will be minus x, no? If it would have been different, we would have taken ratio of equations or 1 divided by 2. But here simple, direct answer. What is answer? Minus x joule. Correct? Okay. They are saying E naught value for this couple is more positive than this. Students, Mn we already know that it has stable configuration everywhere it comes. First understand this concept. Students, we know that delta G is equal to minus NFE. Delta G naught is minus NF E naught. Standard state. If E naught more positive, it means delta G more negative. Delta G is what? More negative. And you know, students, delta G being negative favors spontaneity. That process is feasible. supported. So if E naught is more positive, the process is more delta G more negative, the process is more supported. Means the conversion of Mn plus 3 into Mn plus 2 is occurring at a faster rate, spontaneously. At least faster than these two given in question. Why? Let's check. See, students, Mn configuration is argon 3d5 4s2. If I have to write for Mn plus 2, what it would be? Argon 3d5 4s0. 3d5 is it is a stable half-filled configuration. And if I have to write for Mn plus 3 means one more electron it has lost. It would be, students, argon 3d4. Among this and this, we all know which is more stable, 3d5. So obviously conversion of this into this is supported, no? Why? Because of it is changing from d4 to d5 configuration. If Mn plus 3 has d4, changing into d5, that's it. Right? Okay. Again, students, a direct question. You know that glucose exists in equilibrium with its alpha glucopyranose and beta glucopyranose form. Yes. And it has aldehyde group, but it is bound in the form of a linkage. Correct? Forming a ring, pyranose ring. So only two reagents, one is Schiff's reagent and NaHSO3, because they are weaker bases, weaker nucleophile. They cannot. Why? This thing you know, no? NaHSO3, students, exist as Na plus HSO3 negative. This is the structure. This negative charge is resonance stabilized. If it is stabilized, why it would want to attack? So these two are not strong reagents to break that glucose ring, pyranose ring, and give the test. Rest reagents can give. So which do not give directly, B and E. Correct? Okay. Oh, okay. Students, whenever we have ambidentate ligand, here can we see NO2? It can link as NO2 also, it can link through O also. Whenever ambidentate ligand is present, it always show what? Linkage isomerism. Linkage can be different. Whenever different anions are present, there can be exchange. And it can make another isomer. It can make this also, students. CONH3 5Br and SO4. Correct? If this will go in solution, Br negative is released. If this will go in solution, sulfate ion is released. So they can give different ions, no? So it is what? It is your ionization isomer. Whenever, students, we have complex cation and complex anion, there can be exchange of ligands. We can make different isomers. So what it will give? It will give your coordination isomers. If I illustrate one example, see, we can make this isomer also, no? NH3 from this sphere can move there. I can write as NH3 5 CN and CO CN5 NH3. We can keep exchanging. Only one isomer won't exist. Which isomer? When you get CONH3 3 CN3, and here also CrCN3 NH3 3. Why they don't exist? Because, students, in that case, charges will be balanced. There will be no charge on coordination sphere or coordination anion. Coordination cation or coordination anion. Rest we can draw isomers. Multiple isomers are feasible. So due to exchange of ligand, which isomerism is shown? Coordination isomerism. Here, students, whenever water is one of the ligands, it is feasible that water can go outside also coordination sphere. Yes? And it will give you what? It will give you solvate isomerism. For water, we can also say hydrate isomerism. Like if I show it's one isomer, we can also write CO H2O5 Cl along with 2Cl, 1 H2 is going out. So for D, what is the option 1? Let's check. D1, D1, A2, A2, B3, B3, okay, and C is, okay, C is 4. So option 1. Correct? All right. Next, students. Oh, we have to arrange. See, expected first IE is this LI, BE, B, C, then N. Why expected? Why expected? Because left to right size decreases, correct? So ionization enthalpy increases. Difficult to remove electron. But students, whenever exceptional configuration, exceptionally stable configuration comes, exception comes. Configuration of lithium is, students, helium 2s1, beryllium is helium 2s2, boron is helium 2s2 2p1. Here it is simple, it is stable, but no comparison with O required in N. So here electron in 2s, electron from 2s to be removed, which is fully filled. Here electron from p is to be removed. Due to fully filled 2s having more penetration power. Students, what is penetration power? That 2s is more inside as compared to 2p. See, this is the order of penetration power. Penetration power means closeness to nucleus. S has more penetration power than D, P, than D and F. S is most closest to nucleus if they are of same shell. Like here we have 2s and 2p. 2s has more penetration power. Also it is fully filled S. Because of this, students, ionization enthalpy of BE becomes more than B. There is a jump. So what is correct order? Li, then B, then BE, then regular trend. Got it? Simple. Next. Okay, there is reaction, students. NaOH. We know acid and base react to form salt and water, right? NaOH plus HCl will give you what? NaCl plus H2O. You are given, what I am given with? I am given 1 gram NaOH. And I am given HCl. How much? 25 into 0.75. You know, students, this is your volume, this is your molarity. Whenever I do molarity into volume in ml, I get, students, millimoles. And you know, according to law of equivalence, that according to, students, what? Law of equivalence. I can say moles also of, I can say gram equivalent basically, but see, according to law of equivalence, gram equivalence of this reacting and this reacting should be equal. But students, since n factor is 1, since n factor of both NaOH and HCl is 1, therefore for both of them gram equivalent is equal to moles. Means I can relate in terms of millimoles also, right? So I can say, students, millimoles of HCl reacting is equal to millimoles of NaOH reacting. How do I find? For HCl, students, see, molarity, I've already told, no, use this formula, molarity into volume in ml. If you use volume in liter, you get moles. If you use volume in ml, you get millimoles, right? 0.75 into 25 ml is the millimole. So millimoles of NaOH reacting is also equal to mass reacting of NaOH by molar mass of NaOH. We know molar mass is what? 40. So therefore, mass reacting of NaOH, what it is? This term. It is, students, what? It is 0.75 into 25 into molar mass. What it is? 40 grams. Into 40. Okay, it's in milligram only. Why? Because this I took in milligrams. I multiplied with molar mass only. Got it? This much mass is reacting. Let's solve it. Let's solve this. 75 by 100 into 25 into 40. 25 ones are 4s are 4, 10. What it is? 750 milligram is your amount reacting. What I am given? 1 gram. 1 gram is also equal to, students, 1000 milligram, no? How much amount will be left? Given is 1000 milligram. Reacting is what? 750 milligram. Therefore, mass of NaOH left unreacted would be what? Given mass 1000 minus amount reacting in milligram. So students, it is your 250 milligram. Oh, it is option number 2. Correct? Simple. From HCl I found out how much NaOH. If you feel you want to do in terms of moles, you can do. But later we'll have to convert again in milligrams. Correct? So this is it. Okay, next, students, I'll correct this equation. Equation is 2A in equilibrium with B plus C. For this reaction, students, we are given K equilibrium. What is K equilibrium for this reaction? It is 4 into 10 raised to the power minus 3. I've corrected it here. So this is your K equilibrium. In question, at some instant, concentration of A, B and C is given. Using this data, I can find, students, Q. What is Q? Q is, students, reaction quotient. Q is calculated similar to equilibrium constant. Only difference is that it is at a particular instant, except at equilibrium. How do you define Q? Similar to K equilibrium. Only difference is it is at any other instant except equilibrium. So Q would be equal to concentration of B, concentration of C by concentration of A raised to the power 2. Let's substitute value. What is Q? B is, oh, all values are same only. So if you put 2 into 10 raised to power minus 3 into 2 into 10 raised to power minus 3 by square of 2 into 10 raised to power minus 3, if you solve it, what is Q? 1. You know, it's like this. Reaction always wants to attain equilibrium and hence K equilibrium. If Q is greater than, let me write it like this. If Q value is, students, greater than K equilibrium, then system wants to be at K equilibrium. If Q value is more, system will want to go back, no? To gain that K equilibrium. And if, students, Q is less than K equilibrium, system now wants to go at K equilibrium, then here system shifts. If Q is less than K equilibrium, students, in this case, system shifts in forward direction. And students, if Q is greater than K equilibrium, it wants to decrease value, no? Then system shifts in backward direction. What are we getting here? We are getting Q as 1. What is K equilibrium? It is 0.004. What is greater? 1. So, since, students, Q is greater than K equilibrium, it has tendency to go in backward direction. Got it? Don't get confused. This reaction is this 2A in equilibrium with B plus C, and K equilibrium is 4 into 10 raised to power minus 3. Simple, right? Okay, proceeding then. Qualitative analysis. I'm sure you've done in school also. You know, students, that group 0 has only ammonium ion. Group 1 has what, students? Group 1 has Pb plus 2 ion. Group 2 has what, students? Cu plus 2 ion. Group 3 has what, students? Fe plus 2. We call it Fe. Fe plus 2, Fe plus 3, and Al plus 3. Group 4 has this ion, Mn plus 2, Co plus 2, Ni plus 2, and Zn plus 2. There is a trick. We remember it like this. मेरे को needs जीना. Mn मन को नीजन. मेरे को नी जीना. Right? Group 5 has elements barium, strontium, and calcium. What is the trick to learn them? Trick is BSC. And last, group 6 has what ion? It has Mg plus 2 ion. So Mg is in last. E should be in last. Only first in this. Ammonium there? No. Pb? No. Cu plus 2? Yes. That means B should be in first. 2. After this, Fe or Al? Yes, we have Al. A. So this is answer. Let's quickly check. What is D? D is Co plus 2. See, Co plus 2 is in group 4. Then what we have? C, barium. Barium is in group 5. So option is 1. Next. See, you have to find products, direct reaction. So many times you have done this. When you have 3OH, what happens? 3Cl take what? 3Cl go with R, RCl3, and 3OH go with P. If P is attached to, students, 3OH, what we get? We get, students, H3PO3. So H3PO3 is formed in first, and in second, what happens, students? R is taking 1 Cl, H is taking 1 Cl. How many Cl left? 2, 3. So that 3Cl along with O is your B product, POCl3. You know, students, in PCl5 it has PBP geometry. PBP means 3Cl are along equatorial position, 2 are along axial. Axial ones break easily. 1 Cl goes with R, 1 Cl goes with H, and we get POCl3. Correct? Option 4th. Right? Next. Okay, it's a question of Faraday's law. See, mass in grams of copper deposited by passing this much current. This is value of I. Yes, through a voltmeter. This is your time. You know, students, I is equal to Q by T. You can find Q as I into T. What is current? Current is, students, 9.6487. What is time? Into 100. So your Q is equal to 964.87, which I can take approximately as 965 only. Correct? You know, students, that this is what Q is charge. Q is what? Charge. And we know, students, charge on 1 mole electrons is equal to 1 Faraday, which is 96500 coulomb. How many coulombs we have? 965 coulombs. Therefore, if 96500 coulombs is 1 Faraday, then 965 coulombs would be equal to how much Faraday? 1 divided by 96500 multiplied by 965 Faraday. Correct? 965 Faraday. So how many Faraday of charge I have? So I will have, what dear students? I will have 1 by 100, which is 0.01 Faraday. Why I'm doing this? Because I'm going to write equation. So students, you have to check how much copper will be deposited from copper sulfate. We know na, in copper sulfate Cu is in +2 state. If it takes 2 electrons, it will deposit as copper solid. Now in this reaction, Cu plus 2 ion is aqueous. In this reaction, using stoichiometry, we can say that 2 mole electrons means 2 Faraday charge of electrons deposit 1 mole Cu. What is mass of 1 mole Cu? It is 63.5 gram. How much Faraday I have? I have 0.01 Faraday. So how much moles copper it will deposit? Unitary method. 1 by 2 into 0.01 mole copper. So what is mass? Mass of 1 mole is this, 63.5. What will be mass of this much mole? Multiply. So do this. What it is? 2 3s are 6, 2 1s are 2. Yes, 2 7s are 14. 1 carry, 2 5s are 10 into 0.01. So answer is, students, there are 2 decimals, 0.3175 grams. 0.315. Correct? Yes. Next, students. So next is osmotic pressure versus concentration. You know na, students, what is it? Graph is pi is equal to CRT. If we have to plot y is equal to mx, this is m, this is x. What is value of slope? Slope is your RT. So if I'm plotting with between osmotic pressure and concentration, slope is this much. So students, your slope 25.73 is equal to R. They have given in question. Use R this. 0.083, and T is what? Temperature in Kelvin. T is what? Temperature in Kelvin. So if you solve from here, 25.73 divide by 0.083, what do you get? Answer comes out to be 37 degree in Celsius. You can convert in Kelvin. Quickly you can calculate. You will get answer when you solve in Kelvin. And we know if we get temperature in Kelvin, you subtract 273 from it, you will get temperature in degree Celsius. When you solve it, your answer will come out to be 37 degrees Celsius. Correct? Okay. Simple question, you can solve it. Next, students. Oh, simple. NaCN produces nucleophile Cn-, which proceeds through SN2 mechanism. So what will happen? I will be replaced by what? Cn. We know complete hydrolysis of Cn gives you COH. Partial hydrolysis gives you amide. So what it is? It is your CCC, C double bond O NH2. We can put H, of course. When you are putting NaOH Br2, what is this? Students, this is your Hoffman bromamide degradation reaction, or I can simply write Hoffman degradation reaction. Correct? So what happens in Hoffman bromamide degradation reaction? CO goes away. There is a mechanism, yes. Directly instead of CO, you will attach carbon chain with NH2. It gives you amine. So what is your product C? In this, if you put NaOH Br2, my product is CCCNH2. It is your propylamine. Option 1. Correct? Okay. So, correct statements. three resonating structures can be drawn for ozone? No. Students, this is ozone. O double bond O. Here there is dative bond which I can show as O plus O minus. Other structure I can draw. Here there is double bond. Yes, here there is dative bond. How many resonating structures, students? 2. First statement is wrong. BF3 has non-zero dipole moment, wrong. Students, why? See, BF3 has this structure. Students, dipole moment of these two bonds will be oriented when you find using parallelogram law of vector addition. When two vectors are at 120 degree, the resultant is equal and in center. Here magnitude of vector is same as that of this vector. So resultant dipole moment is, students, 0. It is a non-polar molecule. Next, dipole moment of NF3 greater than NH3. Let's check. Students, in NF3 it has 1 lone pair and 3 F. In NH3 it has 1 lone pair and 3 H. Correct? So see, dipole moment of NF bond is in downward direction. Lone pair movement is in opposite direction. Here lone pair is in opposite direction. Here NH bond also is in up direction. Why? Because electronegativity of N is more than H. In NH3 all vectors are in same direction, additive. Here there is some cancellation. So which has greater dipole moment? Obviously this, no? Dipole moment of NH3 is more than your NF3. So first three statements are wrong. Anyway, fourth statement is apt. Here what is it, students? Here it is CO3 2 minus ion. If I'm drawing resonating structure C, students, carbonate ion, this is your one resonating structure. Other resonating structure is when this bond can be double, negative, negative. Why? There is conjugation. No? This charge moves here, this can move here. Likewise, this charge can move here. This bond will gain negative charge. And third resonating structure possible is this. So total, how many resonating structures we can draw? 3. Only this canonical means resonating structures. Only option 4th is correct. Right? Now see. Students, what it is? CONH36. It is homoleptic, right? Homoleptic means when all ligands are same. CONH34Cl2. Here it is Cl2. This is your Cl2. Right? Is heteroleptic? Right. Heteroleptic means when they are different ligands. Correct? So statement is, it has only one same explanation. It is homoleptic because same kind of ligands. Heteroleptic, different ligands. If there is confusion, I'll rewrite this. Students, in one we have CO NH36 plus 3. In other students we have CO NH34 Cl2 plus. So first is homo, then it is hetero, simple. Correct? So both statements are true. Next, students. Next we are on this 93rd question. So see what we are doing. We are putting KMNO4 in presence of acid in alkene. KMNO4 is a strong oxidizing agent. You know, if carbon of double bond has H, this bond, when this double bond breaks, it gives you acid. If there is no H, it gives you ketone. So what will happen when this breaks? It will give you this. It will give you what product? C will have double bond O, one OH. KMNO4 is strong oxidizing agent, no? If there was no H, students, if there was no H, like suppose here it is R group. This C has H, one side no H. What this will give if I put your alkaline or alcoholic KOH? Here they have taken acidic, same thing. We can take acidic also, we can take alkaline also, right? Suppose I am taking your acidic KMNO4. What will happen, students? This bond will rupture from here. Here there is no H. So it will give you what, students? It will give you ketone. And this side H is there. So this part will give you what? It will give you carboxylic acid. So here simple, it's symmetrical, no? So what product I get? Option 2. Simple. Right. theoretical question, students. Which of the lanthanoid element is diamagnetic? There are three diamagnetic lanthanoids. One is your Ce plus 4, other is Yb plus 2, and third is your Lu plus 3. Check where are they present. So option number is your first. This is not an option, so first, correct. Most of lanthanoids are paramagnetic. Next, okay, we have to consider this reaction. What will be degree of dissociation? Students, they have said these concentrations are at equilibrium. So using these concentrations at equilibrium, first I will find K equilibrium. How? Concentration of N2 into concentration of O2 by concentration of NO square. Put value. If I put, see, what is N2, students? N2 is 3 into 10 raised to power minus 3. What is O2? 4.2 into 10 raised to power minus 3. What is NO? It is 2.8 into 10 raised to power. It is 2.8 into 10 raised to power minus 3 square. So if you will solve from here, students, K equilibrium would be 3 into 4.2 correct, divided by, see, 2.8 square means it is 2 times 2.8 into 2.8. 10 raised to power minus 3 is 2 times, it will cancel out, no? Here square and this will cancel out. This we have to solve. So let's do it. 7 4s are 28, decimal also cancelled. 7 6 are 42, correct. 2 2s are 4, 2 3s are 6, correct. 3 3s are 9, 9 by 2 into 2.8 I can write as 92 into 28. For now I am keeping it like this. Yes, I can solve a bit more, but I am keeping like this, K equilibrium, right. Now what they are saying is this is reaction and I am taking 0.1 mole of NO. What is asked in question, students? Degree of dissociation alpha. What is degree of dissociation alpha? It is moles dissociated by moles taken initially, or amount dissociated by amount taken initially. So students, let's find out how much will dissociate if I'm taking 0.1. How much will dissociate? It is your 0.1 alpha. This much will dissociate. So according to equation, this is equation 2NO in equilibrium with N2 plus O2. If initial amount is, students, 0.1, how much will break? Breakage will be of 0.1 alpha. And N2O2, this is a good question. N2O2 formed are according to stoichiometric coefficient. 2 moles give you 1. So if 0.1 alpha breaks, how much will you get? 0.1 by 2 alpha. How much will you get? 0.1 by 2 alpha. Now let's substitute in value of K equilibrium. What is K equilibrium? K equilibrium is 90 by 2 into 28 is equal to equilibrium concentration of N2 into O2 by NO square, same expression. So it will be, students, 0.1 by 2 alpha into 0.1 by 2 alpha divided by 0.1, take common, 1 minus alpha. 0.1, one thing, I forgot doing square. Maybe many of you have done the same mistake in exam. Do square also, students. Here this I can write like this, no? 0.1 into 1 minus alpha, there is square. Don't forget the squaring part. So when I square, it is 0.1 square into 1 minus alpha square. So 0.1, let me cancel with different pen. Cancelled. What I'm left with? 90 by 2 into 28 is equal to alpha into alpha is alpha square. 2 into 2 is, students, 4. Here it is what? 1 minus alpha square. So I can write therefore alpha square by 1 minus alpha square is 90 into 4 by 2 into 28, right? 4 ones are 4, 4 sevens are 28. Further simplify it. So I can take under root directly, no? So alpha by 1 minus alpha is under root of 90 by 2 into 7. From here, students, it is simplified equation. You can solve it. We can get value of alpha. When you solve it, alpha will come, I think, approximately 0.717. You can solve it. Simple calculation. Right? So this is answer. Only mistake you would have done is forgot doing this, or if you had confusion in alpha, we have done this. Correct? Okay. We have to find empirical formula. What is empirical formula? It is simplest ratio of moles. So see students, moles of C, ratio moles of B, ratio moles of A. Correct? Just a second. One side I'll put A. Let's do it. So how do I find moles? If sum of percentages is 100, we take percent of that as mass only. A is 32%, B is 20%. So percent of C would be 100 minus 32 plus 20. Let's do it. It is 100 minus 52. What it is? 48%. Correct? 2, 5. Yes, 48%. So let's do it. Moles of A, how do you find? What is percent of A? 32 by 64. How do you find B? It is 20%. You can say, no, mass of compound is 100 grams. So percent is same as mass then. And how do I find moles given mass by molar mass? So 20 by, what is mass of B? 40. For C, 48 by 32. Let's do it. 32 ones are 2s are, 1s are 2s are. We can do 16 2s are 32, 16 3s are 48. In order to simplify, I can multiply by 2 all sides. So 2 by 2 is 1, 2 by 2 is 1, 2 into 3 by 2. 2, 2 cancelled. What I get? 1 is to 1 is to 3. So it is A, B, C, 3. Nice. Option 2. Right? Correct. So students, this is direct formula. When work done in a reversible isothermal process, it is minus 2.303 nRT log of V2 by V1. After integrating, we get a direct formula. When to use this formula? When this word reversible and isothermal is given. Also equal to, you know na students, at constant temperature. At constant temperature, P is inversely proportional to V. PV is constant. So instead of V, I can write formula in terms of pressure also. Why? Because they have given pressure, students. This pressure is your P1. This pressure is your P2. Correct? Put value. nRT log of reciprocal V2 instead of V2 by V1. See, if I'm taking ratio, P1 by P2 would be equal to what? Reciprocal. It would be, students, V1 by V2. So instead of V2 by V1, I'll put what? P1 by P2. Now using this formula, I'm solving. See, minus 2.303. They have said 1 mole. N is 1. What is R? They have given in question 2. What is temperature? Temperature is 25 degrees Celsius. So dear students, 25 degrees Celsius is what? Convert in Kelvin. 25 plus 273 Kelvin. It is what? It is 298 Kelvin. So instead of T, put 298. What is P1? P1 is your 20. What is P2? It is 10. Log 2. Log 2 you all know. Log 2 is what, students? 0.30. Log 2 they have not given, but it's okay. Log 2 is 0.3010. We can take 0.3. So see, into 2 into 298, log 2 is 0.3. Just solve this. I think answer will come in calorie because R is in calorie. Answer is with a negative sign. Oh, without solving also we can do. Answer has to be negative. So answer is what, students? Minus 413.41 calorie. It's option 2. There is negative sign, no? In no other option there is negative sign. All right. So again, theoretical question. What is Mohr salt, students? Ferrous ammonium sulfate. This is formula of Mohr salt. FeSO4 dot Al2SO4 thrice dot 6H2O. To prevent hydrolysis of Fe plus 2, so that it does not change into Fe plus 3, does not become ferric, we add some amount of dilute sulfuric acid. We can't add these because concentrated sulfuric acid acts as dehydrating agent also. Yes, and it is strong oxidizing agent also. We can't add dilute HNO3 also. It is also strong oxidizing agent. We can't add HCl because it is reducing agent. When you are further using Mohr salt in titration, it will hamper the process reaction. So we always have to use, students, what? Dilute sulfuric acid. That's it. All right. Next. Reaction rate quadrupoles. Quadrupoles means becomes 4 times. When temperature changes, let's convert this in Kelvin. Okay, so you're given with 2 temperatures. This is also similar to a question which we did, know how to find activation energy using this formula. Log of K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T1 into T2. They are saying reaction rate is becoming 4 times. Means 4 times means, according to this, if your let initial K1 is X, your K2 will be 4 times, 4X. K1 is X at initial temperature. What is initial temperature? It is 27 plus 273. Solve this. 7 plus 3, 10. It is 300 Kelvin. Students, what is T2? T2 is 57. Convert 57 in Kelvin. 57 plus 273 do. 7 plus 3 is 10. 7 plus 5 is 12. 3. It's 330 Kelvin, right? Got it? We have to find what? EA. Let's do. K2 is what? 4x by x. Means it's 4. Anyway, they have given value of log 4 to ease things for us. What is EA? We have to fetch. R they have given? Yes, of course they have given. T2 minus T1. 330 minus 300 is what? 30. So 300 into 330. Therefore, students, what is EA? What is value of log 4? It is, I can take approximately 0.60 or 6. So EA is 0.60 into 2.303 into 8.314 into 300 into 330 by 30. So we will just solve this and we will get our answer. I think we'll have to solve this. What it is? Let me take approximations. 0.6 into 2.3. What it is? 6 3s are 18, 6 2s are 12, 113, 0.6, 2.3, 2 decimals. I've taken it 0.6, right? 8.3 into 100 into 33. Let me take it just 8.3. This is your 3300. We will multiply it further. So if I do this, I can take it 1.4, right? I will get approximate answer, but not an issue. 1.4 into 8.3 into 3300. So if I do 83 into 14, correct? 3 4s are 12, 8 4s are 32, 133, 3 8. It's your 1162 into 33 into 100. So putting decimals, 2 decimals, no, will come. Taking it 12, too much approximations, no problem. 33 into 12, let's do it quickly. 3 2s are 6, 6, 3, 3. What I'm getting? 39600. That means it's sure, it's in kilojoule, right? So if I do divide by 1000, what it is? It is approximately 39.6 39.6. So we'll go with 38. Why my answer is varying? Too much approximations. But I had an idea, no? It will be 39 point something. Closest is this, right? Yes, calculation was lengthy, but I'm sure you would have done like this way only or solved it completely otherwise, right? Okay. Last question, students. Okay, it's a pretty easy question. We know PBr3. It is source of what? Br negative. It causes SN2. So instead of OH, what will come, students? We will get Br here. Alcoholic QH causes what? Elimination. Different products are possible. H can go from here also. H can go from here also. But which is major product? According to Sidzef rule, the more substituted is major product. So the major product would be when H is eliminated, students, from left side. Because if you eliminate H from right side, this would be, students, your minor product. So check option. It is option number A. All right. So that's it. We have discussed. I'm sure you have done well. You can go through it. If you need any help in counseling, you can get in touch with us. We, as a support system of Ellen, we can guide you through this journey. And students, if you feel that you could have done better, you want to improve your score, you want multiple revisions and reattempt, then you can join us for the upcoming leaders batch too. Right? We are free to entertain your queries. All the best. Take care. Have a good day. Bye, students.